To track our sun's dark future, we travel back in time to its beginning. These exotic clouds of gas and dust are called nebulas. They consist of the remnants of dying stars. But upon closer observation, they're actually stellar nurseries, where stars like our sun were born.
About 4.5 billion years ago in our galaxy, a giant cloud of gas and dust gradually was pulled together by gravity. And as gravity caused that cloud to collapse, a lot of energy was released, it heated up, and finally in the center, nuclear reactions started, changing hydrogen into helium, and a new star was born.
The remaining stellar material swirled around the newborn sun. It collided and coalesced, eventually sculpting the 8 planets in our solar system, including Earth.
When that happened, a stellar wind turned on and cleared out all the extra material, leaving the planets that we have today and additional bodies, some of which collided or merged with the other planets.
Among the billions of points of light in the universe, our sun is an average star. There are stars 100 times its mass. And contrary to its appearance, the true color of the sun differs from what we see when it rises and sets.
The sun is actually a white star, not a yellow star. It's white, like this car. Now, it's true that the peak of its spectrum is sort of in the yellow region, but it also emits some blue light and green light and orange and red, and all those colors together are perceived by our retina and our brain as the color white.
Our sun has a lot in common with humans. When it was young, it was extremely active and often unpredictable.
What we found was really very surprising. We found that stars like the sun, when they're very young, are rotating much, much faster than today. If you can imagine something as big as the sun just whipping around in one day or even less, that was a very different kind of sun. It was having all kinds of eruptions that blasted particles through space that hit the Earth.
Right now, our sun is middle-aged and has settled into a quieter, regular schedule. But it's still generating a lot of energy.
The sun right now is about 4.5 billion years old. It's slightly under half of its total anticipated lifetime. So it's kind of like this car with a little bit more than half of its tank still full. The sun now is burning fuel, that is, fusing hydrogen to helium. at a steady but ferocious rate. It's like a 90 billion megaton bomb going off every second. It's just an incredible amount of power.
On Earth, we're actually only receiving about 1/2 of the energy that's being produced at the sun. Now, on a daily basis, that's enough energy to power about 29 million billion 100-watt light bulbs for 1 hour. The amount of energy being generated in the interior of the sun is just enormous.
Our sun will continue to churn out energy over its entire lifetime, which is estimated to be around 12 billion years.
On a clear night, away from city lights, the sky is full of stars, more than we could possibly dream of counting, right? Well, if there were a grain of sand for every star that we could see with the naked eye, 9,096. That's it, every star bright enough to be seen from Earth without the aid of a telescope. With bigger eyes, we can see a lot more. This is the Andromeda Galaxy, the nearest major galaxy to the Milky Way, and it's full of stars. Earth is surrounded by 360 degrees of space in every direction. Take an arc of 1 degree and divide it into 60, and that's an arc minute. This 1.5 billion pixel image from the Hubble telescope covers about 1,000 square arc minutes and contains more than 100 million stars. Let's put that into perspective. If it was brighter, this is what Andromeda would look like next to our moon. But we don't have to look at an area of sky that big to find 100 million stars. Let's take a closer look at this little piece of sky. The Hubble telescope was aimed at this sliver of sky. Its shutter opened for 2 million seconds, and from a seemingly empty corner of space emerged not stars, but thousands of galaxies. Some of these are as old as 13.2 billion years, photons emitted near the beginning of the universe itself. The faintest objects in this image are 10 billion times dimmer than we can see with our own eyes. To cover the entire sky, it would take 30 million squares the size of this Hubble Extreme Deep Field. Scientists estimate that the observable universe contains about 200 billion galaxies. If, instead of stars, we made every grain of sand a galaxy, it would fill 27 cubic meters. So, how many stars are there? Maybe 1 septillion. That's a number that's so big that it doesn't make sense. But one thing we can be sure of, there's not enough beaches on Earth to hold them all. Carl Sagan said that Earth is the shore of the cosmic ocean. So remember, each night when we look up at a sky seemingly filled with stars, we're only dragging a finger through the sand. Stay curious.